So I just picked up some coffee grounds from my local coffee shop, and we're going to try to make biochar out of these using just solar power from the Fresnel lens. But first things first, these are pretty moist, and so I have to dry them out. Otherwise, we're just going to be using all the heat to evaporate water, which is super expensive thermodynamically. And that's just going to be putting it out in the sun to get it down to about 10 to 12% moisture. So it's about 20 minutes past solar noon here, but these will definitely dry out in just a few hours. Alright, it's been like a day or two, and I think a lot of my coffee flew out because of the wind, but it's very dry. So now I'm just going to load up my charcoal maker thing. Alright, so this is pretty much loaded to the top, and in the bottom I had painted this with soot, candle soot. And now I'm putting it into the star of the show, which is the Fresnel lens designed specifically for this. I gotta be careful here because if I put my hand in the wrong spot, it's going to burn. Time is right now. My grandma tapped me to ask if she can talk during the video, and I said no, but now I said yes. So anyways, solar noon, I gotta angle this better, of course. Like this. There we are. This is absolutely the hottest possible time of the day. It's the maximum solar energy. Let's get cooking. I'm gonna put a rock under this to get it a little bit better. So it's been just over a minute in the sun, and right in the center, you can see the peak temperature I'm hitting right now is about 215. And the reality is, thermodynamically speaking, this could be a lot better. So of course I can't change the total sun energy hitting there. However, it is windy. So if I put a little bit of a barrier around, it would help a lot because the wind is taking away a lot of the radiative heat, as well as a better insulation. All around it is just cat litter, which I just picked that because that's all I have, but in reality that's not a great insulator. I'd much prefer a steel wool. No, what am I talking about? Not steel wool, rock wool, but a high temperature one. Because I do have a different type of foam, which they use for houses, like this insulation, but that one was only up to 75 Celsius. So it would warp, it would off gas. I don't want that. So I do need to get something better. However, it's good. Also, another way I could increase the temperature would be by painting this even better black. Reality is, it's quite reflective right now, which means that a lot of the energy is being lost. The darker that is, the less that should hurt my eyes, which is, you know, safety squints is not the best test, but yeah, right now, oh, you saw it? 220. We hit 220 right there. 226. So I'll leave this for a bit. I'll come back later. So I've just adjusted the height of this to decrease the area of the focal point, which should theoretically increase the temperature. And I see a little smoking, and you could see now, right in the center, we've hit temperatures of 300. 301 we've hit. Let's see here, max. However, of course, what you gain in temperature, you're losing in area. And so this would make a smaller amount of charcoal, but faster. And definitely possible because of pyrolysis, temperatures is 300 Celsius. And so it really is a trade-off balance. So by increasing the area of this, if I got a bigger lens, I would be obviously able to make more charcoal. Oh, it's falling. And of course, I have to figure the stance better. So I'm gonna leave it right now, and I'll take you to the 3D modeling now to show you the design. So real quick, also just to show you the 3D model of how I designed this system. The way I do it is in Blender, and the focal point and the size of the Fresnel lens, I know it's 30 centimeters in diameter with a 40 centimeter focal point, so it's quite easy to do. And then I just modeled out my holder, I modeled out everything I needed, exactly with the tube sizings that I have, and all I did after that was send it to the 3D printer, which is, this is what it looks like, and then I 3D printed it, of course, and that's how I set it up. I just had lunch and came back, and this is why I should not leave this unattended. Yeah, that's not good. Oh, let's check it out anyway for a moment. Cool down. Oh, there it is. It smells toasty. This is, I would say, biochar, because Wow. I'm impressed. It's hot. And I will move this inside. Well, it really ain't much, but it is honest work, as they say. And this is definitely biochar because it was baked 300 Celsius with no oxygen. And proof of concept works. Now it's a matter of scaling this up and fixing all the little issues. But that's just engineering. My grandma doesn't believe that there's any color difference. But this one is regular coffee, dried, and this is, let's say the biochar. This is what it looks like if you put the regular coffee. A little bit of smoke. Now let's try this. Yeah. Okay, so that's there. Let's see if I can get this to light on fire. Same amount of time. Okay. Seems they both work. Yeah, maybe less than a little. I don't know what we made in here. Okay, this is the difference. If I blow on this one, that's the way it goes. If I blow on this one, okay, that is biochar. Το βλέπεις? Όχι. Αν κάνω φυσάω σε αυτό, κοίτα. It doesn't spread when I blow on it. Εδώ. This is more biochar than other. It's a mess here, but something's up. Leave in the comments what you think. Well, for the new stand, collecting some soil. You'll see shortly why. Okay, I'm hoping this big bottle of soil will be the new holder. And in this way, I can aim it any way I want. It actually looks promising already. Alright, it's kind of a windy day. I'm not going to restart the experiments. It's a little bit dangerous, but just to quickly show you proof of concept of this stand, totally works. In any angle I want. So, probably better to wet this. But yeah, you can actually see the focal point when I do this. See? Right above. Yeah, I can pull it out. Yeah, this is good.